Welcome to Center of Math, Unusual Properties in Math. Today we're going to show a function with a discontinuous derivative and a function with an unbounded derivative. So first, a differential function with a discontinuous derivative. So we're going to take f of x equals x squared sine 1 over x when x does not equal 0, and f of x equals 0 when x equals 0. Note this is continuous, is that as x approaches 0, sine 1 over x is bounded between -1 and 1. And so we just take x squared less than some epsilon. Clearly, since this is less than 1, this will be less than the epsilon. So this will go to 0 as x goes to 0. So this is, in fact, a continuous function. It's also differentiable at 0. F of x minus f of x naught at x equals 0. X equals 0 is just 0. So f of x over x is x sine 1 over x. Again, this x sine 1 over x, again, will go to 0. So the derivative at 0 will actually be 0. And so, yeah, f prime of x equals 2x sine 1 over x minus cosine 1 over minus cosine 1 over x when x does not equal 0, and 0 when x equals 0. So this, as x goes to 0, the 2x sine 1 over x approaches 0, since again sine 1 over x is bounded between -1 and 1. So x goes to 0, cosine 1 over x, it oscillates between -1 and 1, an infinite amount. So as we approach 0, it'll just keep oscillating, and so it's discontinuous at x equals 0. No matter how close we get to 0, no matter what neighborhood we take around the point 0, there's always going to be points at 1 and -1. So now we're going to give an example of a function with the derivative, and the derivative exists on a closed interval, but is unbounded on that closed interval. So we're going to take f of x equals x squared sine 1 over x squared if x does not equal 0, and 0 if x equals 0. So now when x does not equal 0, clearly it's differentiable. When x equals 0, it's the limit as x goes to 0 of x sine 1 over x squared, which approaches 0. So f prime of x will equal 2x sine 1 over x squared minus 2 over x cosine 1 over x squared when x does not equal 0, and 0 when x equals 0. So note, we can take a closed interval to be -1, 1. So note, as x goes to 0, this left term, 2x sine 1 over x squared. Sine 1 over x squared is bounded between -1 and 1. X gets as close to 0 as we want, so this will approach 0 as x goes to 0. This term on the right, minus 2 over x, is unbounded as x goes to 0. Cosine 1 over x squared will oscillate between -1 and 1. And so as we approach 0, this right term will just keep oscillating higher and higher and lower. And so if we take -1 and 1, we take any closed interval containing 0, we'll have a section that just keeps oscillating higher and higher. And so it will be unbounded on that closed interval. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. And if you like this video, please check out our other unusual properties in math videos in our playlist. Thank you.